Lesson 2-6, the intermediate value theorem and its consequences. Give an equation for a continuous function f and a value of y between f of a and f of b. Find a value of x equal to c between a and b for which f of c is equal to y. Let's take a look at this curve and try to understand what we're talking about here. We have y is equal to x cubed. We know that at x equal to 1, x equal to 1, y is equal to 1, and at x equal to 2, y is equal to 8. And the question is there an x value where y will be equal to 6? So is there an x value? 6 is between 8 and 1. So the intermediate value theorem says, yes, there'll be an x between 2 and 1 that'll go with this y value of 6. And according to the discussion right here, it looks like it's very close. It's between 1.81 and 1.82. And one of the reasons why we can get this value is because this is a continuous function and not a set of discrete points. So we know that as x goes from 1 to 2, it must take all the values from 1 to 8, and at one point it should have 6 as well. Here is the intermediate value theorem. Notice that the condition is that it's continuous, and y must be between two other y values, and that guarantees that the input value for y must be between a and b itself, the open interval. All right, let's take a look at an example where we have a cubic function again, and we want to use the intermediate value theorem to make a conclusion about whether there's a value, an x value that goes with the number 5. Okay, so x is equal to 1, and when x is equal to 1, we get the value y is equal to 4. Or 6, and at x is equal to 3, the y value is equal to 4. So we want to know if we're going to be able to get a y value that is 5. So this is the intermediate value between 6 and 4. And because it's continuous, and we know that polynomials are continuous, that we know that we are going to have to be able to go through all of the x values from 1 to 3. So yes, there will be an x value between 1 and 3. And you can use your calculator to find it. It looks like there's probably more than one value. No, just this value, because it looks like this one is outside the 1 and 3 right here. Now the theorem is an existence theorem. It doesn't tell you how to find that x value, it just says it exists. Let's take a look at these pictures right here. You can see this function is continuous. When we have an intermediate value between two y values, we know the x value that goes with it will be within the between the interval a and b. Now notice that this is not continuous, so we may or may not have a c value, intermediate value that has an x value that's in the interval. Now if the c happened to be up here, it would occur. The theorem is an existence theorem which says if you meet these conditions, you'll always be able to find it. And in this case, depending on where c is, you may find it or you may not find it. All right, let's take a look at this graph. We have an intermediate value here that's between f of a and f of b. And notice that we're guaranteed, the theorem guarantees that we're going to have an x value that's in the interval. It just so happens there's going to be 3. And again, it's an existence theorem which says there will be one. It doesn't tell you how many, nor does it tell you how to find them. One of the biggest importance of the intermediate value theorem is the idea that there must be a root. If you have a function, again, that's continuous, and one y value is negative, and the other y value is positive. So again, we have to run through all the values from negative to positive, and 0 will be one of them. That's an intermediate value, and we're guaranteed that there will be an x between a and b that'll satisfy that. And this is the end of the screencast.